So these are the basics of the physics behind Webb. Now, what were some of the things that astronomers were thinking about when they said, hey, let's build this large infrared optimized telescope? Well, you might imagine they had plenty of things they wanted to do. So initially, it was this emphasis on finding the first stars and galaxies. But since you can see those first objects, you can now watch them evolve throughout cosmic time. So you can do a lot of experiments, as it were, about the structure and how it builds up in the universe. You can begin to penetrate, because infrared radiation penetrates gas and dust clouds more effectively than optical light. So you can watch stars forming in dust clouds within our own galaxy. The second to last question up there was something that we didn't think about when we were first conceiving Webb, because in the early 90s, does anybody know what the exoplanet count was in the early 90s? Well, it was, when we were started at Webb, there was 2. We knew about 2 around a pulsar. There was no way you could observe them with Webb. But it really wasn't part of the initial thinking. Now, when we talk about the instruments, you'll see that we actually will be super capable, but it wasn't really by design. It was only because of the incredible power of some of the instruments. So just for comparison here, people may be more familiar with Hubble. This is just a little statistics comparison between the two. So Hubble's mirror is about 2.5 meters in diameter. Webb is 6.5 meters in diameter, so more collecting area. Hubble is pretty beefy as far as telescopes go. It got to ride up on the shuttle, so they didn't really have to worry about mass, saving mass that much. We had to worry about that a lot. We were just a bigger observatory, so even though we are a larger collecting area, we're about half the mass of Hubble. Our wavelength coverage is from the reddest parts of where your eye can see out to the mid-infrared, whereas Hubble can see a little bit into the infrared out to the ultraviolet, so different wavelengths optimization. Hubble's a room temperature telescope because it's in low Earth orbit. Because we're infrared optimized, we want to be cold because you don't want to see the signal coming from your telescope. So our telescope is very cold. And also, unlike Hubble, we will be far away. Hubble was accessible by the shuttle, got repaired. We're going to go 1 million miles away, 1.5 million kilometers away, and we'll talk more about that later. Last point there, Hubble went up on the shuttle, and because we're a partnership with the European Space Agency, they are giving us a ride on their Ariane 5 rocket.